Oh boy, yet another 3D printed ITX computer case on YouTube. Yeah, I know it's been done, but I need a new PC. As of late, I've been spending every day of the week in my new studio, Mandic Labs 2.0. But that means I went from being home, working from home every day, around our animals, around the family, to just not being there. I need to change it. I need a computer for my home office. That way, on days where I don't need to be hands-on with projects, I can be doing 3D design work, emails, or some light video editing from home around the family and spend time with them. But I don't want to build yet another top-of-the-line, water-cooled, heat-pumping workstation to get my work done. For home, I can go a little bit lower power, but still powerful. So in this video, we'll be designing, 3D printing, and assembling my new home office ITX. Yes, 3D printed case, but thinking outside of the box. Of course, to design this, we need the parts we're going to use to build it so we know how big everything is. I've really got to build stairs. Up to here, the ladder is getting really old. I've had the parts for this project for a little while, definitely since the last studio, so we can dig them out of storage and find the heart of what we need. This new Minis Forum main board, the BD790i X3D. This was provided to me by Minis Forum. They're not sponsoring this video, but thank you to them for sending us over for this project. Popping off the heatsink of this thing, you can see the heart of it. It's a bare bones board with a laptop processor on board, namely a Ryzen 9 7945 HX3D, 16 cores, 32 threads, and 3D V-cache for gaming performance and workstation use. It allows for Gen 5 NVMe drives like this 1TB PNY drive that I'm putting in for really fast storage. For RAM, it takes SODIMM memory. I'm going to be using this Corsair Vengeance DDR5 4800 MHz 96GB kit. We had to get the RAM and the SSD installed so we can now install the fan on top of the heatsink. Of course, I need a fan for this, so it's off to my only fans drawer. Fan I'll be using for this is the Noctua Redux 120. They're gray, they'll have a good look for the overall build, and they're a little more affordable than the other ones, though they don't come with vibration dampers on them, but we can take care of that with some 3D printing. You see, Noctua is one of the companies that has some of their files available for download on printables. I was able to get the Vibration Isolator CAD step files and remix them myself to make them more 3D printable. I loaded up TPU in one of the Core 1s and was able to print off a set of my own in about 45 minutes. I'll put the remixed file on my printables account so you folks can print these too. They press into the corner of each fan, and the little nubs get a little help with a pair of pliers to pull through and snap into place, giving me vibration isolators without having to order anything. I just printed them myself. Now I can install onto the heatsink of the BD790i with confidence. With a fan topping off our heatsink, our board is bare bones no longer. It's ready to roll, except for a graphics card. Now we could use the GPU that's built into the CPU on this, and for a lot of applications, that'd be plenty. But CAD work, video editing, and let's face it, gaming, I'm gonna want a discrete GPU. So in comes this one, the MSI Aero ITX. This is an RTX 3060, so it is 2 generations old, but it is a 12GB variant, which is good for CAD and video editing purposes. There are faster GPUs out there, but this form factor is just lost right now. There's really not a good upgrade path from this particular card that I already had, so it's what I'm going to use. Our last pretty critical component when we're talking about the design is how we're going to power this, the power supply. I cheaped out on this project. I'm going with this Amazon special Apevia, supposedly Flex ATX, but not really. It's got modular power connectors on it. They call it an ITX power supply. It's 500 watts, which should be plenty for the hardware we have in this setup, and even maybe give a little headroom for a hopeful video card update. Is it gonna blow up on me? Am I gonna regret it? I don't know. But with this in hand, we can test our hardware on the bench before we go designing a whole case around it to make sure it's all going to work together. Of course, to do a proper boot test, we need to look for video output from the hardware. And that's where this video's sponsor, KTC Monitors and their new MEGAPAD A25Q portable monitor come in. This is a 24.5-inch IPS screen with a 5,000 milliamp hour battery inside of it to get you up to 3 hours of runtime away from the wall. The screen features an anti-glare coating and low blue light output for eye health. The build quality is surprisingly solid on this thing. It weighs in at 5.5 kilograms, and the overall design just feels solid. When Ruby saw it for the first time, she said, wow, they put a lot of effort into making the back of that thing look beautiful, the part you're rarely gonna see. But when you do look at the back, you can find the swiveling kickstand on here. It allows you to go from the landscape orientation to portrait. Now, why would you want to go to portrait orientation on this? Well, this is also running Android 14. It has a Qualcomm processor, 8 gigabytes of RAM, 128 gigs of storage. It is an Android tablet as well as being a portable monitor. That means I can take this thing on the go with me and I can still get things done without even having to have a computer. I can do emails or scroll through TikTok and, keep up with the social feeds, because that's part of my job, okay? The IPS screen has excellent image clarity and vibrant color reproduction. With the USB-C input, you can use this with a wide range of devices as an external monitor. But I do have to say, for me, I think I'm really excited to use this as a tablet, mount it on the wall somewhere in the new studio and use it for a home assistant dashboard and have a beautiful big display to run whatever I want to on Android. Whether you need a portable monitor, a big Android tablet, or both, consider checking out the A25Q5 at the link in the description today. Thank you again to KTC Monitors for sponsoring this video. Now let's go ahead and test out our hardware with the screen. With all of our electrical connections hooked up, we can short across a couple of pins on the motherboard, and we have liftoff of the hardware. A short moment later, we get some output of video to the monitor, and a spiffy BIOS pops up. We have this stuff up and running. I should note the monitor has a USB-C input, so I did have to figure out how to connect it to this particular hardware. I don't have a DisplayPort to USB-C cable floating around. I only have one that goes the other way, so I had to order one. We'll test that later. For now, I was lucky the motherboard has a USB-C output, and that worked out just fine, as you can see. We can head into the BIOS and confirm that everything looks like it's okay. Our full 96 gigabytes of VRAM are currently detected, and we're ready to roll forward with this project, which means it's time to design. When I said that I want to think outside the box with this design, I was speaking fairly literally. If you look on YouTube right now, there are 3D printed ITX cases on there, but most, if not all of them, are just rectangular boxes. Don't get me wrong, some of these look fantastic, but this is 3D printing. We're not limited to just using flat sheet metal bent in a press brake anymore. That said, I don't want to be so outside of the box that it's just an open concept. I need this to be an enclosed case that can have filters on it because, well, fuzzy, fluffy cats. So what I've landed on is a design that Ruby jokingly dubbed the bent box, and the name has stuck at this point. I didn't get quite as far outside of the box as I wanted with this design, mostly because when I sat down to get started on it, I had a full-on ADD executive dysfunction day where in 12 hours worth of sitting here, I accomplished nothing. Those days don't hit me often, but when they do, they are very frustrating. So I just had to go with what design I was able to get done with my mental capacity at the moment. So maybe we'll revisit a more outside of the box design later. Here's what we've got. An angular paneled, integrated RGB diffusion, and random exhaust vents design with some cyberpunk flair. Internally, I'm aiming for positive air pressure. So we've got a pair of Noctua 60mm fans in the bottom, blowing up through, creating a chimney effect. Air can escape out of the random exhaust vents, as well as the motherboard I/O and the GPU backplate. There are 3 windows to both highlight the hardware on display and the RGB lighting that will be coming, though the side one has taken up a lot of it with an inlet for fresh air to get right to the CPU cooler. The power supply and PCIe riser cables were particular pain points because I couldn't find 3D files of them, so I had to make my own from scratch. If you go to the links in the description and you pick up those parts for your project, you'll find the 3D models that I created to design this on my printables page to help you out. I'm sure I could spend a whole video talking about design elements on something like this, but realistically, I think we need to go get it 3D printed so we can see it come together and highlight those design points in the real world. So let's get to it. You may have noticed that my office is a hunter green. I would like to repaint it, but I don't want to do that right now. So I'm going to go with a neutral color for this project. I'm loading up some Ambrosia ASA filament so it'll handle the temperatures of a 3D printed computer case, and I'm using a neutral gray color, galactic gray for the outer casing, which has a sparkly aesthetic to it, and just their classic gray for the highlight and secondary components. I'm also using translucent PETG for LED diffusers. We'll see more of that as we get to the RGB. And this is one of the first projects where this new Prusa Print Farm studio sponsor is really getting to shine. I ran all of the parts on the Core 1s, the Mark 4s, and the XL, all 10 machines going. The entire total print time was just over 105 hours. That said, that number is deceptive. It's a guesstimation, but I believe that I could have printed all of the parts for this project in half that time if it wasn't for how I printed them, which was mostly overnight. If I'm running a 3-hour print that's gonna finish at 2 a.m. when nobody's here to clear the plate off, there's not really a reason to bother printing it as fast as I can. I will slow my machines down when I'm running overnight prints to make maximum use of the available time. If I'm gonna be at home in bed anyway, when I come in the next day, the print's finished, that's all that matters to me. Slowing down improves print quality and strength on any machine. It doesn't matter what it is. These can print fast and well, but there's no reason to push it if you don't have to. With all the machines loaded up with finished prints, it's time to get them cracked off the beds and get this thing assembled. Sticky sports. We're first going to assemble our outer shell, the entire outside rim of the design, as that will make up the main body, and then there's a front and a back panel. It's held together with M3 heat press inserts, brass threaded inserts. Using a heat press insert tip and a soldering iron, I could just press these into the plastic. That and button head M3 screws are the hardware that's going to hold almost everything together here. I could have used 632 screws for the motherboard mounting, as that's what's traditional for a PC case, but there would have been one standard hardware piece with everything else being metric. It didn't make sense to me. Then there are tie pieces, connector pieces that will overlap between two sections and either get screwed into or have screws pass through them into the chassis. As I'm seeing the case come together, it's quickly clear that installing the hardware now is the smarter move. I could wait and do it in a fully assembled case, but cable management and mounting everything will just go smoother right now. First, I'll mount the motherboard into the top of the case, and then I can secure the PCIe riser cable to its mounting bosses at the bottom so it's ready to support the GPU. I mentioned earlier that the CPU fan is drawing fresh air through a filtered inlet on the side of the case. Well, this duct is how it's getting airflow guided to that side inlet. Our two 60mm Noctua inlet fans get mounted with typical case screws that came with them into the bottom of this chassis. For power and reset, I got some of these billet buttons with LEDs inside of them. I honestly think these things are a little played out. I've used them in cars for a decade or more now, and I'm pretty tired of them, but they were an easy option here, so they're what I'm going with. I've mentioned a few times that I want the air inlets for this case to be filtered, so it's time to experiment. I've 3D printed my own fan filters. This is a 1.8mm hex grid that I designed on an insert that'll slide into the bottom of the case. The first revision is pretty tight, so that'll need some work, but the goal is to block out cat hair and rogue dog fluff without choking airflow. Hopefully it works, only one way to find out. With the primary case structure assembled, we can put the back panel onto this thing. This is a point where I decided to add some flair. Something I like to do is using actual print parameters as a detail. In this case, Hilbert curve on the top layer of this print, I think looks great and gives it some nice fun texture. The power supply slides in from the front and mounts to the back panel and then rests on some standoffs inside the case. With that installed, we can get to cable management, which I think turned out okay for not really planning it that much in the design. A lot of cables are hidden underneath the motherboard and behind the GPU riser cable, and I'm okay with that.
And now, before we put the front panel on, our last step is RGB, one of the most important critical steps to this whole build.
The LEDs that I'm going to use for this are these SK6812s. I have a strip of them already sitting around, so it's what I'm going with. These are RGBW, so you get color and a cool white chip on this particular one. For mock-up, I'm using a little bit of blue painter's tape and just running it around the outer edge of the case so I can get it where I want before I cut things. You may notice there's a gap at the front of the case that I intended specifically to run this RGB strip around. I left a little room there for it to sit, including getting the mounting bosses for the front panel away from the case edge so that the strip could go behind them.
You may think, okay, great, now you're just going to plug that into your motherboard and you've got RGB. But no, this motherboard doesn't have an RGB header at all. So I'm going to be using one of these.
The Y'all board. ESP32, open source, Wi-Fi enabled, and running WLED RGB Control firmware. Studio sponsor PCBWay sent this one over, so big thanks to them for powering the RGB chaos and the rest of the chaos at Mandic Labs 2.0.
There is one other challenge that this little board brings up. That is, how do I power it? And well, how do you power anything in a computer? With the power supply, I'm going to hack the SATA cable and take the 5V out of it and feed it into the WLED controller that I just dropped.
This is definitely a don't try this at home thing. I can't recommend tagging off of your 5V rail on your power supply to power a random SBC, but here we are, it's what I'm doing. If you've ever installed these RGB strips, you probably know the adhesive on them is hot garbage, even if they claim it's good stuff. I applied VHB tape to the back of mine to have a stronger hold, and I found that really works well. After a bit of movie magic time, we've got the RGB installed, cable managed, and ready to run. Watch this. I want to see how fast WLED boots. Ready? Booted. I loved that. Honestly, it's kind of impressive in a way that, like, you're not stealing system resources as many RGB softwares will on a computer. It boots faster and honestly has a wider range of controls in some ways. You're not going to get your game integrations, but I don't really care about that. I might consider doing this on more PC builds in the future. For now, let's change out the color to something Mandic Labs. Then we can get the front cover installed on this thing. Looking closely at the face of this, you'll see the Hilbert curve make another appearance. I used that as the infill pattern for the first layer on this print, reduced Z offset so that it didn't squish too much, and it gives you this really unique pattern look to things that I personally am addicted to. I love the way it looks. Something unique you can do with 3D printing, just changing up a couple of settings and get a different look to it. That said, you may notice there's no windows in this thing currently. I don't have a laser in the lab right now, so we're going to have to head to the house and use the laser that I gifted to Ruby at our home makerspace. As we head to the house to get the windows cut for this project, I want to thank you folks, those of you who directly support what it is that we do here. Whether it be through Patreon, YouTube memberships, or heck, the folks who came out for the painting party locally and helped me paint the studio. You are all so greatly appreciated in helping to directly make this work. The new studio means a lot more overhead, which has meant an uptick in sponsor reads, and I appreciate you folks for sticking with me and directly supporting. More folks who support through these platforms, the less I need to take on those sponsor reads, and I would love to have that happen. Those of you who can't justify directly supporting, I totally understand, and I appreciate you being here anyway. Dropping a like, subscribing, commenting, those things all really help out and don't cost you anything. Now let's get this assembled and head back to the studio, because I left some of the supplies I need there. In the front panel, the windows drop right in, and then a front cover trim piece sandwiches them into the panel. That is held by its own screws and a couple screws that pass through it into the main case. The CPU window on the side has the cutout for the CPU inlet fan, but it needs magnets installed in it so that the filter can attach to it. Some CA glue and activator gets those installed really quickly, then the 3D printed filter gets magnets just press fit into it. The inlet cutout isn't the largest, but it should allow good fresh air in through. The filter just snaps right onto the side of the case. And really, that filter tops this off. There's performance numbers and more design things to talk about, but let's take a look at the completed case. A fun detail you may have noticed by this point is the light strip all the way around the perimeter of the face of the case, so even in the dark you can see the shape of this thing. I'm really happy with the way that came out other than LED hotspots, but I pained about how to make this detail. I landed on the easiest method, which was making it in multiple pieces that lay on top of each other and then printing it on the Prusa XL. So the outer and inner pieces are ASA with an interlocked piece of PETG that is translucent in between them, so that can be the light strip diffuser. I don't use the XL as much as I would like to because I know not everybody has one, and I don't want to be designing things that require this machine, but it really does unlock a lot of possibilities for my projects. And printing this all in one piece like this means that there's no gaps in the edge lighting, and I just really love the way it turned out. With that last design element covered, it's time to go ahead and fire this thing up, do some benchmarking, and see how this 16-core 7945HX processor compares to my 5950 that's in my main workstation. See what it can do. Okay, test results are in. I am amazed with this little laptop processor on this ITX motherboard. I don't know why I was underestimating it as much as I was, but it's the little CPU that can. This thing in Cinebench R23, multi-core, it turned in 32126 versus the 24120 of my 5950X. Single core, it turned in a 1950 versus a 1580. A laptop processor is making me think that my current everyday workstation is getting a little long in the tooth. Now we need to test the whole package, the GPU, the RAM, everything together. I ran 3D Mark, their Nomad test, the one I could run in the free demo version of 3D Mark. The new ITX PC turned in a 1928. My old computer, 5751, a 66% faster score for my old computer. That 3060 is really showing its weakness right now. You see, I have a 3090 Ti in the other computer, and it's pretty clear which one is still the workhorse. I'm honestly tempted to run this thing as my main computer for a little while. It's seriously impressive hardware in a fun package that I built myself. The big thing that holds me off on that is this has 2.5 gig Ethernet. Great, I have 2.5 gig at home. Here I have 10 gig and 2.5 gig for different devices. That's a downside for this particular use case. For home, it's going to be great. How am I feeling about this project at this point? Honestly, there's things I would do differently. I'm going to do one of my debriefing episodes, a little vlog video talking about the things that I would change or do differently, what I didn't like about a project. That's available for my Patreon members and YouTube members as well. So you can find that probably as soon as this video goes live. For the rest of you, I do have to say, I wanted to design something a little bit different, but I'm really liking the way this ended up looking, and the performance of it is no slouch, so I'm really looking forward to using it as my home work computer moving forward. When I first started this project, I had every intention of releasing the design files so you could make one of these for yourself. At this point though, now that I've built it, however happy I am with the final result, I don't think it's release ready, and I really don't have time to make it release ready. There's just enough things about it that are finicky, or you need a Prusa XL for the front panel, things like that, where I don't feel like it's ready for prime time, and I don't want to release it to the public as a result. That said, YouTube members and Patreon supporters, I am going to release the files for you folks. I know, another thing behind a paywall. The reason for that is Those folks generally have a more direct line to me where we can chit chat and talk about what's working and what's not working, and I feel like it's just a better avenue to release files for something like this where I don't feel like it's ready for the widespread mainstream release. And since it's the only metric I think small form factor folks seem to care about, this is not a particularly small case. The best I was able to figure out, it's somewhere between 13 to 14 liters in size, so I could definitely see scaling this down. I've got ideas about another iteration of this down the road, or a full-size ATX build, possibly. Let me know in the comments if you want to see me take another crack at 3D printing a computer case, something I wanted to do forever, and I'm happy I finally did it. All right, time for me to pack this thing up, get it home, and spend more time around the family. Ironically, I'm wrapping this video up at about 5:45 a.m., and I've been here since yesterday, so it's coming at a time when I really need it. Hope you found this video interesting. If you did, drop it a like, it really helps out. Let me know in the comments what you thought of this project, and get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. Hope you get more sleep than I do.